Hello, today I will introduce some common structural forms and major. First, before we start it, we need to understand some basic requirements of design of buildings. For example, if this is a very super tall building, you need to have consider the dead load, knife load, and wind and or earthquake will be the control one. Also, if you want to reduce the size of a columns, you can increase the strength of a columns. And if you don't want it, you can increase the stiffness by increase the thickness or increase the depth. And we also need to consider human comfort and fire. And another basic step you need to understand for a wall, if the window is up high in here, the wall is very stiff. But if the window is perpendicular to a wall, it will be very weak. This is a very basic principle you need to understand. That means you can imagine you push a little force to a paper, it will easily buckle or collapse. But if you put the force near parallels to the paper, it is much more difficult. That means you can consider this one y direction is very good, but x direction is not good. That's why there's a typo error in here. And then you need to understand, if more rigid of the building, the less deflection. That means the building is very stiff and very strong. Normally we control the deflection is 1 to 500. And I will introduce some form for you. And the first one I will talk about the based frame structures. Most likely this is a steel building. They use the brace to take the lateral force. For example, if the lateral force apply in here, they will have a compression and tension force, and then they can resolve it the lateral force. And this is some of the examples. And the second one I will tell you is the rigid frame. Most likely this is also a steel frame structures. This is up to 25 stories. It's like the vertical load they can take it. The bending they also can be taken by having a rigid joint. Most likely the rigid joint they may have a stiffener like this, have horizontal plate to transfer the loading, because they need to take the moment and make a strong connections. Sometimes if the connection is not good enough, they need to have a stiffener. That's why they have a strengthening in here. And the third one I will talk about the shear wall structures. I think the most typical concept is that if you have a symmetric one, the system is much more better. But if you have an unsymmetric, it will be very poor. And you can see this building have a shear wall on the sides of the building, and the bottom is also have a shear wall. Another thing is called the wall frame structure. It is combined of the shear wall with a rigid steel frame, and some of the example is like this. Another thing is a framed tube. That means the external column is taking all the wind load, and the internal column is just take the gravity load. That means you can see the window should be very small. This is a disadvantage. But I think most likely low and below the ground, above the ground floor, most likely we need to have a transfer structure. Otherwise, if they have many columns go directly to the ground floor, it will construct the congested. And this is another type I will show you, is a base framed steel braided tube in tube. That means external have many columns combined, and also inside have a core is also tubed. The sixth one is an outrigger system. Most likely this is very common for the super tall building. The concept is try to let the columns help to take the window and make the lever arm much more larger, and then take the loading and make the building become more stiff. They just combine all the core wall and columns together, and you can see something like this. And the column also can help to sharply reduce the bending moment due to the wind of the core. And then this is a very common form. They will combine all the core wall or the column by the steel frame, and also they have a bell truss to connect all the columns together. That means you can imagine this is one pieces of structures. And the last one is a core structure. That means they do not have any column below. They just provide the core to take the vertical load and lateral load. Sometimes they will use the cantilever beam or cantilever slab, and then they have a much more column free space for the end user using. Okay, this is another example. You can see the bottom level, they have a very large entrance, and the column free may be very useful. Okay, this is the end of the presentation.